I want you to think about the last time you ordered takeout on your phone. You're sitting on your couch, you're hungry, so you open an app, you scroll a bit.
Right, checking out the pictures.
Yeah, exactly. And you tap a button, and then, well, you just wait. And 30, maybe 40 minutes later, a hot meal magically appears at your front door.
It feels completely effortless, just pure convenience for the user.
It really does, almost like pure magic.
Yeah.
But behind that single, simple button press is this massive, highly synchronized digital ballet playing out in real time.
Oh, absolutely.
Oh.
I mean, we experience it as just a tap on a screen, but the reality is you are triggering this incredible cascade of complex algorithms.
Right.
Real-time data transfers, logistical coordination. It's frankly staggering when you look at the underlying architecture.
And looking at that architecture is exactly our mission for this deep dive. We've got our hands on a highly comprehensive behind-the-scenes development guide.
It's really thorough source, yeah.
It details exactly how to build a food delivery platform, specifically a clone of a market giant like Deliveroo. So we're going to completely demystify the tech stack that brings you your dinner.
And we'll uncover the specific economic mechanisms these platforms use to actually generate cash.
Which is wild. Plus, we're going to reveal exactly what it costs in engineering hours to build an empire like this from scratch. Okay, let's unpack this. Because using a food delivery app is less like reading a digital menu and much more like interacting with a digital air traffic control system.
The air traffic control analogy is spot on, actually.
Yeah.
The biggest illusion of a food delivery platform is that it's just one app.
Right, because I only have one icon on my phone.
Exactly. When you tap that icon, you assume you're interacting with a single, unified piece of software. But in reality, you are only looking at the customer-facing terminal.
Just the tip of the iceberg.
Yeah. A platform like Deliveroo is actually a synchronized ecosystem of 4 entirely separate applications. Each one is built for a different user persona, and they're all talking to a centralized server simultaneously.
So the invisible quartet, basically. You have the customer app, the restaurant app, the rider app, and the admin dashboard. Let's break down the technical load of each one, maybe starting with the customer app.
Sure. And this isn't just, rendering a static catalog of food.
No, the heavy lifting really comes from the real-time tracking architecture. We're not talking about a vague delivery window here.
Right, like your food will arrive between 5 and 6.
Exactly. Nobody wants that anymore. We are talking about live, minute-by-minute map integrations plotting a rider's actual GPS coordinates over a geographic API.
All while handling concurrent payment gateways ranging from Apple Pay to localized digital wallets.
Right. And while your app is rendering that map, a completely different software environment is running in the kitchen of the restaurant.
Yeah, the restaurant app. And that thing has to manage state changes instantly. I mean, imagine if a kitchen suddenly gets hit with a rush of 50 physical walk-in customers.
Get chaos.
Utter chaos. So the expediter needs to be able to toggle their digital capacity. They need a release valve.
So they can just pause the incoming digital orders.
Exactly. Or, if they run out of a specific ingredient, that inventory data has to push to the central server and instantly update the customer app so nobody else can order it. It requires flawless state synchronization.
Wow. And then you introduce the ultimate variable, the physical world, the rider app. These couriers are essentially running a micro-business directly from their smartphones.
They really are. And their app requires background geolocation tracking, which, by the way, is notoriously tricky to optimize without draining the phone's battery in like an hour.
Oh, I bet. And it also has to run continuous proximity algorithms to decide which rider gets pinged for which order, right?
Yes, and calculate dynamic routing based on live traffic APIs, plus compute net earnings on the fly.
Factoring in base pay, tips, and platform commissions, that is a ton of data moving constantly.
It is. And tying all 3 of those distinct applications together is the admin dashboard.
The central nervous system.
Right. Operated by the platform owners. It manages the load balancing, handles multi-region database syncing.
Runs automated background checks for new riders.
Yep. And oversees the multi-currency payment flows.
Yeah.
It's this overarching logic layer, ensuring that a state change in the restaurant app properly triggers a notification in the customer app, while simultaneously dispatching a command to the rider app.
So if I'm understanding this correctly, we essentially have a situation where the customer, the kitchen, the courier, and the corporate office are all operating in entirely different software environment.
Completely different, yeah.
But they need to communicate with zero latency. How are developers actually achieving that synchronization? Because, if I have to keep manually pulling down to refresh my screen to see where my pizza is, the whole illusion of convenience is just broken.
What's fascinating here is the shift in how we handle network requests. So traditional web architecture relies on the HTTP request response model.
Which means what exactly?
It means your phone asks the server for data, the server sends it, and then the connection just closes. It hangs up.
Oh, so if I want an update, I have to initiate a brand new request.
Exactly. But for a digital air traffic control system, that latency is completely unacceptable. So developers rely on WebSocket protocols, specifically libraries like socket.io.
Meaning they aren't just pinging the server and hanging up, they're keeping the line open.
Precisely. Socket.io establishes a persistent, full duplex TCP connection between the client and the server.
Full duplex, so data flows both ways at the same time.
Right. It allows for real-time, bidirectional, event-driven communication. The second a chef taps order ready on their tablet, that event fires a JSON payload through the open WebSocket directly to the server.
Which then instantly pushes that state change down the open connections to both your customer app and the writer app.
Yeah, exactly. There's no polling, no refreshing, it's immediate.
That's incredible. But maintaining tens of thousands of persistent WebSocket connections across 4 separate applications, that requires immense server loads.
Oh, huge loads.
The AWS bills alone for running that kind of concurrent, real-time infrastructure must be astronomical. How does a company justify that back-end overhead when I'm only paying like a $2 or $3 delivery fee at checkout?
Well, there has to be a deeper economic engine, right?
Yeah.
Because the delivery fee you pay is largely just a psychological decoy.
A decoy.
Really? Yeah. It covers basic logistics, maybe, but it is nowhere near enough to sustain the business model. These platforms actually operate on about 7 different concurrent revenue streams.
7. Okay, walk me through that.
So the absolute lifeblood, the main artery of their income, is the restaurant commission. On every single order, the platform takes a cut of roughly 15 to 30% directly from the restaurant.
Whoa. I have to push back on that because the math there seems impossible.
That sounds steep, I know.
If I buy a $10 burger from a local independent diner, the platform is taking up to $3 at that transaction. The restaurant still has to pay for the ingredients, the line cook's hourly wage, the lease on the building, the electricity.
I have that, yes.
And the margins in the restaurant industry are famously razor thin, usually hovering around, 3 to 5%? How does a local business survive handing over 30% of their top line?
If we connect this to the bigger picture, you have to look at how restaurant economics shift from variable to fixed costs. Yes, taking a 30% cut of a $10 burger seems brutal on paper.
It seems like highway robbery.
But think about the restaurant's rent, their utilities, and their baseline labor. Those are fixed costs. They are paying for those whether they sell 100 burgers or 150 burgers.
Ah, I see. So the only true marginal cost for that digital order is just the physical ingredients and the packaging.
Exactly. The platform argues they are providing purely incremental volume. By listing on a platform like Deliveroo, a neighborhood diner suddenly has geographic reach and visibility to tens of thousands of users who would never walk past their physical storefront.
So it's basically marketing.
Right. The platform essentially acts as a hyper-efficient marketing engine. The 30% commission is viewed as a customer acquisition cost. The volume of new incremental orders is supposed to offset the steep margin cut.
Okay, that makes sense. So that handles the primary revenue stream. But you mentioned 7 streams. The guide details things like customer subscriptions too, right?
Yeah, like Deliveroo Plus, for example.
Where you pay a flat monthly fee to waive delivery charges. Now, on the surface, that looks like a perk for the user, but behavioral economics would suggest it's actually a trap to shift the user's lifetime value, right?
It entirely changes user behavior. Once a customer pays that $10 monthly subscription, the sunk cost fallacy kicks in.
They feel compelled to order more.
Exactly. They order more frequently to, get their money's worth out of the free delivery. The platform trades the minor revenue of individual delivery fees for a massive increase in order frequency and long-term retention.
Which drastically improves their ratio of lifetime value to customer acquisition cost.
Spot on.
Then there is the stream that probably causes the most friction with users, surge pricing.
Oh yeah, people hate that.
You open the app on a rainy Friday night, and suddenly the delivery fee is $8. The instinct is to view this as corporate greed, just price gouging because it's raining.
But from a system architecture standpoint, surge pricing isn't just about padding the bottom line. It's actually an algorithmic tool for localized liquidity.
Liquidity, like having enough drivers.
Right. A food delivery platform is a two-sided marketplace. You have to balance demand-hungry customers with supply-available riders.
So when demand spikes, the algorithm senses a lack of liquidity in the rider pool.
Exactly. If there are 500 orders in a 2-mile radius and only 50 active riders,
Hmm.
the system will just collapse. Deliveries will take 2 hours, food will get cold, and users will churn.
So the surge pricing algorithm dynamically raises the cost to suppress customer demand.
While simultaneously using that extra capital as a financial bounty to lure offline riders out of their apartments and into that specific geographic zone, it balances the marketplace in real time.
It's literally behavioral manipulation coded into a routing algorithm. Fascinating.
It really is. And rounding out the revenue, the guide also highlights premium restaurant placements.
Which is essentially selling digital shelf space. Just like a grocery store charging a brand for eye-level placement on an aisle.
Exactly the same concept. Plus, there are high-margin cross-selling partnerships, like prompting a user to add a 2-liter soda at checkout, or teaming up with local grocery chains for rapid convenience deliveries.
When you aggregate all those 7 streams, the 30% commissions, the subscription retention, the algorithmic surge pricing, the advertising real estate, you begin to see how a platform scales to generate billions in gross merchandise value.
Yeah, it adds up incredibly fast.
Which naturally leads to the million-dollar question. Seeing the revenue potential here, let's say you, as an entrepreneur, want to build your own localized food delivery ecosystem.
Okay, let's say you do.
What is the actual price tag on engineering this 4-app digital air traffic control system? Here's where it gets really interesting, because the source material lays out 3 distinct development paths, and the cost variations are massive.
Yeah, the path you choose dictates your time to market and your capital runway entirely.
I look at this through the lens of real estate. The first path is building entirely from scratch. This is like hiring an architecture firm to build a bespoke custom mansion on an empty plot of land.
Right, very expensive.
It requires a dedicated engineering team, 6 to 12 months of development time, and the costs are astronomical. Realistically, this path is exclusively for massive enterprises with highly unique operational models that off-the-shelf software simply cannot support.
And for the vast majority of founders, building from scratch is just an unnecessary burn of venture capital.
Because the hard problems are already solved.
Exactly. The core operational challenges of food delivery cart management, payment gateways, geographic routing have already been solved. You don't need to reinvent the wheel. That leads to the second pass, the clone app.
Right. And the clone app is like buying a customizable suburban home in a new development. The foundation is poured, the plumbing is routed, but you get to pick the finishes.
It's much faster.
The guide notes this takes about 3 to 6 months, but the pricing tiers are what caught my eye. A small, basic clone runs $40,000 to $70,000.
Pretty reasonable for software.
But if you want a quote-unquote complex app, the price balloons to $120,000, even north of $150,000. Why does cloning an existing architecture still cost $150,000? What specific engineering hours are driving that premium?
So the leap from $40,000 to $150,000 really comes down to edge case handling, third-party integrations, and machine learning models.
Okay, break that down for me.
Sure. A basic $40,000 app gets you simple CRE operations. Create, read, update, delete. You can make a profile, browse a menu, and check out.
Pretty standard stuff.
Yeah. But a $150,000 build incorporates complex AI for localized food recommendations. It involves integrating expensive third-party APIs like Twilio for SMS masking.
Oh, right. So riders and customers can text without seeing each other's real phone numbers. That's a huge privacy feature.
Exactly. And I imagine the routing algorithms become much more sophisticated at that price point, too.
Yeah, you are paying for advanced solutions to the traveling salesman problem.
Wait, what does that mean in this context?
Well, the system needs to calculate how to batch multiple orders from different restaurants to a single rider based on live traffic density, all while ensuring the first order doesn't get cold.
Oh, wow. That is a brutal math problem.
It is. Furthermore, a huge chunk of that, $150,000, goes into rigorous QA testing, quality assurance. Because if a network drop causes a state synchronization failure during the payment loop, you lose the customer's trust permanently.
Right. If you mess with someone's credit card, they never come back.
Exactly. You are paying for stability under load.
Okay, but there's a third option for those who don't have $150,000 or 6 months to burn. The white label solution.
Right, the third path.
To stick with your real estate metaphor, this is moving into a fully furnished apartment. The lease is signed, the furniture is there, you just bring your clothes.
A white label solution provides a pre-built, production-ready code base.
The architecture is entirely finished.
So an entrepreneur simply applies their brand styling, configures their local payment gateways, and can deploy the entire ecosystem in just 2 to 6 weeks. It drastically lowers the barrier to entry.
And regardless of whether you drop 150 grand on a customized clone or license a white label script, the underlying tech stack driving these platforms has become highly standardized, hasn't it?
It really has. The industry has converged on a few highly efficient frameworks. On the client side, the front-end mobile apps, the dominant technology is React Native.
Which is brilliant, because React Native functions like a universal power adapter. Well, in the old days, you had to hire a Swift developer to build the iOS app for iPhones, and then a separate Kotlin or Java developer to build the Android app.
Oh, right. 2 separate code bases, 2 separate teams.
Exactly. But with React Native, you write the JavaScript code base once, plug it in, and the framework natively compiles it for both Apple and Android processors. You are effectively halving your mobile development costs.
That's a great way to conceptualize it. Universal power adapter.
Ah.
And when we look at the back end, the database architecture, storing all this information, the industry heavily favors NoSQL solutions, particularly MongoDB.
I want to pause on that, actually, because I think a lot of people default to standard relational databases like PostgreSQL.
Yeah, that's what you're taught in Computer Science 101.
Right, and especially when you are dealing with financial transactions and order histories. Wouldn't you want the rigid schemas and ACD compliance of a SQL database? Why are they using NoSQL?
It comes down to the nature of the data payload. A SQL database requires a very rigid schema. Think of highly structured tables where every row must have the exact same columns.
Okay, like a giant Excel spreadsheet.
Exactly. But restaurant data is incredibly unstructured and highly variable.
Right, because a sushi restaurant's menu structure looks nothing like a customized pizza joint's menu.
Exactly. A pizza might have 50 different modification variables, half-and-half toppings, crust styles, extra cheese, all of that. If you try to map that immense variance into a relational SQL database, you end up writing incredibly complex, slow join queries across dozens of tables just to render one single menu item.
Which would kill your latency.
Yes. So MongoDB is a NoSQL database that stores data as flexible, unstructured JSON documents. It allows the platform to ingest any type of restaurant menu with infinite modifiers without constantly having to rebuild the database schema.
So it prioritizes speed and scalability over rigid structure.
Exactly. Okay, so you've secured your capital. You have your React Native front end looking gorgeous on iOS and Android. Your MongoDB backend is efficiently serving up complex JSON payloads, and your WebSocket connections are just humming along.
Sounds perfect.
You launch your platform, ready to reap those 30% commissions. You've won, right?
Far from it, unfortunately. The business graveyard is overflowing with beautifully engineered code bases.
It really is.
The source material spends significant time detailing the harsh operational realities of this market. Code is truly only half the battle.
The first major pitfall highlighted is completely ignoring the MVP framework, the minimum viable product.
Yeah, this happens all the time.
Founders raise capital and immediately try to build the $150,000 complex architecture on day one. They spend a year coding AI recommendations and custom routing, only to launch and discover their local market doesn't actually have the population density to support the liquidity network effects required for the business model to function.
In software development, you have to validate your assumptions quickly. Deploy the basic $40,000 MVP, test the local unit economics.
See if people actually want it.
Exactly. See how your specific user base interacts with the cart, and then allocate your remaining capital to iterate based on real behavioral data rather than assumptions.
The guide also emphasizes the sheer logistical nightmare of data security. You aren't just moving burgers, you are processing thousands of localized credit card transactions.
And if your encryption and tokenization protocols aren't flawless, you are looking at devastating regulatory fines.
Not to mention post-launch maintenance. If your AWS servers buckle during the Super Bowl halftime rush, which, by the way, is the ultimate stress test for concurrent WebSocket connections, your users will simply download a competitor's app and literally never return.
But perhaps the most sobering reality is the sheer brutality of market saturation. You can have perfect code, zero downtime, and massive capital and still fail.
Which brings up the most fascinating piece of real-world trivia in this entire guide.
Oh, this blew my mind.
Right. We are talking about Deliveroo, the gold standard platform that this entire architecture is based on. In 2019, Amazon led a massive $575 million investment round into Deliveroo.
Just a phenomenal war chest of capital.
Right. Literal Amazon-level money and infrastructure backing them. And yet, in August of 2019, just months after securing that funding, Deliveroo had to completely shutter their operations and exit the country of Germany.
They retreated entirely.
How does a company with the literal blueprint for success, backed by hundreds of millions from the biggest tech giant on Earth, get entirely pushed out of a major European market by local competition?
This raises an important question. What actually defines a durable competitive moat in localized tech? Deliveroo had world-class engineering. They had unlimited capital. But in Germany, they were outmaneuvered by a rival called Delivery Hero.
Delivery Hero.
Yeah. And Delivery Hero didn't win because of better WebSocket connections. They won because of hyperlocal operational dominance.
They understood the physical battlefield better than the digital one.
It's exactly. Delivery Hero cultivated deeper, entrenched relationships with the local German restaurant syndicates. They built a far more efficient localized fleet management system tailored to German infrastructure.
Wow.
They dominated the customer acquisition channels so thoroughly that the cost for Deliveroo to acquire a single user became mathematically unsustainable. It proves that software is easily democratized, but local operational logistics are notoriously difficult to scale across borders.
It's the ultimate reality check, isn't it? You can buy the exact same digital air traffic control system as your competitor, but if they have locked down all the exclusive landing rights at the local airports, your planes have nowhere to go.
Perfect analogy. The white label solutions and affordable clone scripts have absolutely democratized access to the technology. Anyone can enter the arena now.
Literally anyone with a bit of cash.
But once you step into that arena, you still have to possess the operational ruthlessness to fight the gladiators.
We've covered incredible ground today. We started by looking at a simple tap on a smartphone screen, and we peeled back the layers to reveal a synchronized ecosystem of 4 distinct applications communicating via full duplex WebSockets.
It's quite the journey.
We dissected the $150,000 engineering cost, explored how unstructured JSON documents in NoSQL databases handle chaotic restaurant menus, and exposed the algorithmic liquidity mechanisms driving surge pricing and those crazy 30% commissions.
And finally, we looked at the unforgiving corporate warfare, where even Amazon-backed giants can be driven out of a market by superior local logistics.
It really reframes the narrative, doesn't it? The complexity hidden just beneath the surface of our everyday convenience is an absolute engineering marvel, but it's tethered to an incredibly fragile economic reality.
It is. Clean code is only the entry ticket. Operational execution is the actual product.
The next time your takeout arrives at your front door as you're grabbing that hot meal, you won't just be thinking about the baseline delivery fee. You'll be visualizing the dynamic routing algorithms, the persistent TCP connections, and the real-time database synchronizations working tirelessly in the background to make that single moment possible.
It kind of ruins the magic, but in the best way possible.
So what does this all mean? It means that while the barrier to building complex, real-time digital architecture has never been lower, the barrier to scaling a profitable, localized marketplace remains exceptionally high.
Absolutely.
And it leaves me with a final thought I want you to chew on. If a modern white label solution makes it this incredibly fast and affordable, just a few weeks and a fraction of the cost, to completely clone a global tech giant's entire digital infrastructure,
Yeah.
what other massive tech monopolies out there are currently sitting comfortably, completely unaware that they are just one really good $40,000 clone away from being totally disrupted by a clever local entrepreneur?